Hello everyone and welcome to this new YouTube tutorial where we are going to be talking about how to create good colliders for your simulations, VDB colliders, VDB surface, because usually we don't have a really good geometry and when we try to use the typical VDB from polygons node, if the geometry is not close or doesn't have a volume or it changed topology and holes are moving per frame, it's going to be a bit difficult to create the collider. So we're going to be going through different examples, and at the end of the video, I hope that you find some of them useful, so you can implement them into your workflows, or yeah, at least you learn something new about this topic. Okay, so for the first sample, we are going to be using this plant model, which, as you can see, is a model without volume. Uh, those are just single-sided faces. And if we try to use a VDB from polygon for this model, it's going to create a really bad collider, as you can see. This is not something that we could use inside the simulation. So the first method that we could think about is just scattering a lot of points in the surface so we can get a good point cloud representation of what the surface is, and then just use the VDB from particles node and the VDB reshape in this case set to close, which is nice because it's going to give us, well, basically the close operation is performing an expansion and then shrinking back the geometry by the same amount, so we could get rid of holes, valleys that our surface could have. Also, we are going to be doing this same setup for an animated geometry. In this case, I'm just bending the plant from side to side. It's a really basic animation. I'm not an animator, so yeah. And then we are just stopping the animation, just time shifting animation to frame number one, scattering again a lot of points and making sure that we have the primnum attribute and the primuv attribute enable, because we are going to use the attribute interpolate node, which is going to make sure that each point on each frame belongs to the same primitive number and the same UV position of that primitive, and that is going to give us a nice point cloud that is not going to be jumping from frame to frame. And then again, just use the typical VDB from particles node and VDB reshape, and we could have a good collider in an animated geometry. Okay, so for this second example, we're going to be using this model, which is some kind of stairs. I'm not very sure what is this, but the thing is that we have a, a model with pieces that are open, which doesn't have volume, so this is going to give us a weird collider if we try to use the typical VDB from polygon nodes. So we are going to create, first of all, we are going to create a class attribute because we are going to be looping through each piece based on that class attribute, and we are going to be filtering the geometry in terms of, hey, this geometry needs some kind of treatment, or hey, this geometry is okay and we don't need to do nothing to it because it's closed, has a volume, and the VDB node is going to be, like the VDB from polygon node is going to be working nice on that one. So yeah, we're going to choose one of the more problematic pieces. In this case is this one. And we are going to create a group which is going to be based on the unshared edges of a geometry. So this is going to allow us to see if a piece has unshared edges, so if it's an open geometry. And then we just need to create an attribute. In this case, I'm calling the attribute open. Then we just need to promote the point attribute to detail and promote that back to 2 points. And this way we will have an open attribute with a value of 1 for the whole piece. And this way we can filter the whole piece using a split node. We are going to filter this, as I said, using the open attribute. For treatment, we could use two different type of process. The first one will be using the typical polyextrude, and the second one will be using this thicken node, which is coming from the labs library of nodes. The thicken node has a cool option of extruding the geometry in both directions, and that would be nice if we want, in some cases, to extrude the geometry outwards and inwards at the same time by the same amount. But yeah, it's up to you how you want to do it. Depends on what you're looking for. But at the end, it's doing the same, just in different ways. And after all this, I'm just giving the geometry a color. For you can see that if a piece was manipulated inside our loop, or if it was a correct piece and we didn't need to do nothing to it. And now if we try to use the VDB from polygon node and create this VDB collider, it's going to work fine because we close the geometry. Yeah, it's going to be a good collider for your simulation. Okay, so for the third example, we are going to be taking our crack geometry and converting to polygons because it's a pack geometry. We are going to sort the primitives in a random order based on the frame. So I'm not sure if you are going to be able to see this, but each frame, the primitive number is going to be changing for the whole model. So when we try to blast this number of primitives, it's going to be changing each frame, which is nice because we will have a more complex geometry. So yeah, first thing that we are going to try is to use our first method of scattering points using the VDB from particles node and see if this is working. Of course, it's going to work, but the thing is that this representation is not the best. It's working, but the problem is that we are creating inside geometry because at the end we are just scattering points. Those points are going to have a p-scale and it's going to give us let's say a geometry with cavities inside, and this is not what we want. So we will need to come up with a method of deleting these holes in the inside if we want it. In this case, I'm just creating a volume per piece based on the class attribute that we created, and then deleting the small parts based on that volume. But this is not the best way to do that. It's going to work, but also the surface representation is not the best. I'm just showing you that can be done, and we will have good colliders in terms that we don't have holes, but it's not the best way. Okay, so next approach, same geometry, we are deleting a bunch of primitives, changing per frame, and the VDB from polygon node is not working correctly. So I found this cool node called Remesh grid, which basically if we set this to surface type to be a thin plate and we refer to the documentation, we are going to see that basically what it's saying is that a thin plate treats the existing surface as a flat sheet and builds a new one, closed surface, by offsetting a distance around the sheet. This is exactly what the documentation says. So basically it's going to create a more accurate surface based on the based on the input surface that we are feeding to this node. And we also have some cool options in here in this node to delete or erode the surface or do some kind of smooth operations to the geometry. So it's some type of geometry manipulation node that also deals with VDB manipulations. Then use the typical VDB from polygons, and if we want, we could use a VDB reshape and erode the surface a little bit, and we will have a nice collider for our simulation. Okay, next example, same geometry. We are blasting a bunch of primitives, so we have a really bad geometry. And in this case, we are creating a class attribute based on the primitives. And we are using this convex decomposition node, which basically is going to loop through each piece based on that attribute, and it's going to give us a convex piece. This way, each piece is going to be closed, of course. So it will work perfectly fine if we try to convert this to a collider using the typical VDB from polygon nodes. But if we want to get a more accurate representation of the input geometry, we could basically remesh the surface, because right now the surface that this convex decomposition node is giving us is not the best, so we can remesh it to get a more uniform look or a more uniform topology. And then we could ray this new uniform geometry into our bad topology geometry, and this way we will get a more accurate surface. So then when we do the VDB from polygons and the VDB shapes and all type of VDB operations, we will get a more matching surface or matching collider to the first one. And this method worked really good in this case, so I think it's a good option to consider it. Okay, next example. In this case, we are changing the model, but it's the same. I'm not sure why I was time shifting the model and converting to polygons, because this is a packed geometry. It's not a packed geometry, and we don't even need this connectivity node to create the class attribute. So it's the same than before. We are just sorting the primitives and blasting them, a lot of them, and we have a really bad geometry. That is not going to work if we use the typical VDB from polygon node. But the thing here is that we are going to create a box based on the bounds of the object, and we are going to remesh the box, because we need more topology, more points in this box, because we need to perform some kind of operation that needs to have more geometry, otherwise it's not going to work correctly. And we are going to enter a loop where we are going to ray this box into the bad topology geometry. And then we just use the typical VDB from polygon node to convert it to a VDB, and then back to polygons using the convert VDB, and we perform this loop as many times as we want. And as you can see, each time that we loop, we are getting a more interesting surface, a more accurate surface, which is closed, so it has a volume. It's working nice if we try to convert it to polygons, and that's what we are doing right now. We are just using the typical VDB from polygon node and VDB reshape node to get something close to to the result that we would like. And as you can see, we went from something really bad, uh, really bad, to a really nice close uh, collider that is going to work nicely inside the simulation. This is more like an experimentation that I was trying. It's not the best way to do it, but I just wanted to show you that as long as it gives us a nice collider, you can use whatever method that you like. So yeah, same geometry, blasting primitives, VDB from polygons not working. We are computing the normals of the model. And then what we want to do is create a vector attribute. In this case, I call it cross, because what we're going to be doing is computing the cross product between the up vector and the normals of the model. And if we display this attribute, will be, well, these are the normals, and this is the cross vector. What we want to do is looping again. We are using a lot of loops. In this case, the loop is set to merge iterations, because we want to keep what we did in the past iteration and merge that with the current iteration. And what we are going to be doing is offsetting the position using the cross product, multiplying that by an amplitude factor. And this way, I'm not sure if you can see it, but we are just offsetting a little bit the position of the same model, the same topology. And then we are going to ray that back into the model that was like before that we tried to offset in the position. And as I said, we are going to be merging each iteration, as you can see in here. So we will have a combination of all the iteration that we did in the model. Again, scatter out of points. In this case, I'm using a point cheater to have a more random distribution of points and rain that back into the geometry that we calculated after the loop. And then we can use the typical VDB from particles node, which we've seen that before. And this is going to give us again a collider, so we can work with it in the simulation. But yeah, this was more a experimentation approach. So yeah, I just wanted to show you another way.